Good evening, students. I will start with the class. In the previous class, we had seen Bernoulli's theorem. I'll just revise it again. As per Bernoulli's theorem, what does it say? Suppose if there is a pipe, okay, there is water entering, maybe water is leaving here. And with reference to the ground, if it is at some height, so this one is at height h2, the ground level. Then there's something called as the total energy. The total energy of the water or the fluid, whichever it is flowing from here to here. Okay, consider at this point, suppose if it is entering with velocity v1 and the pressure also p1, the area also a1 were before. Okay, so the total energy is always equals to pressure energy plus kinetic energy plus potential energy. Pressure energy is given as P, kinetic energy may be half, rho v square. This is where rho is the density. And then potential energy will be mgh. So instead of m, it is rho gh. We know that the potential energy formula is mgh. So this will be in terms of fluid. So density, we'll use it as rho gh. Now this is what it tries to say, it is constant. Constant means at the start also if you try to calculate this energy would be same at the end. So this is a total energy formula. Pressure energy plus kinetic energy plus potential. Now as per Bernoulli's theorem, what is happening is if you calculate the total energy here, it should be same as this point. So which is leaving at suppose P2, pressure 2 is here, V2, and this is A2. So as per that, on the left hand side, this will become P1. Density anyways will remain the same in the liquid. So this will be V1 square. For this circle I'm writing. Plus rho, gravity will not change whether it is here or here. So it will be G. Here it is height H1. It will be same as at the right hand side. So this will be P2 here. So it's half rho V2 square rho G H2. So this is what Bernoulli's theorem says. The left hand side, whatever is here from this formula, I just put it as 1, which will be same as total energy at the end. Now if the pipe is straight, suppose, and you know that at both the places height will remain the same, you have to take h1 equals to h2 equals to h. If it's a straight pipe, then h1 will be equal to h2. So based on that, there's one question. These are two questions are there based on Bernoulli's theorem on the last page of your notes. I will anyways give the question. They are already solved, but they might be little confusing to you. I'll just explain. Calculate total energy possessed by 1 kg of water where pressure is 20 grams force per area, velocity is 0.1 meter per second, and height 50 centimeter above ground level. So this is the question. Now the data given is pressure is given as 20 grams per millimeter square. Means it is what? It is in terms of millimeter, but our standard ones are should be in meters. Velocity is given in meters per second. So I have to convert it into standard units. Everything should be in terms of meter now. As for that, what it will be is 20 into 10 raised to minus 3 millimeter into this. This is 10 raised to minus 3, and already this is minus 4 millimeter means when you take it on top, it will be 10 raised to minus 2. If you want to use that way only, see. This is given as upon millimeter square in the question. So this will be 20 grams. If I want in terms of kgs, it will be 10 raised to minus 3 kg. And then again into or upon 10 raised to minus 3 the whole square. Why? This is meters. This is for grams to kg, and this is for millimeter to meter. 10 raised to minus 3 meters, and that's the square. Now calculate 20 into 10 raised to minus 3
No, sir. Sir,
into 10 raised to 6 upon 10 raised to minus 6. If you take it on top, it will become plus. So they've taken this G as not grams, huh? This is taken as gravity. So not even mentioned in the this, just write where G is for gravity, huh? Gravity force per millimeter square. Because you cannot make out actually. This looks like grams for this. 1 second now. And we'll have to use it as let's correct this 20 into 9.8 f upon 10 raised to minus 2. 20 into 9.8 into 10 raised to 6. Just write this much only and keep. I'm not going to solve the same way how they have solved in the notes, huh? Because that will be confusing. So don't refer the note solution, just refer here this 20 into 9.8 into 10 raised to 6. Because this will be minus 6. If you take on top, it will be plus 6. So keep it as it is. So this will be I'll calculate at the end. Now, what else we need? Total energy, we know that. Any other data given? Velocity is given as 0.1 meters per second. That is correct. Standard unit. Height is 50 centimeter. Now again, we have to convert this 5 into 10 raised to minus 2. Okay. Density of water, even if they don't give, you have to know it is 10 raised to 3. Right, and keep density of water is always 10 raised to 3. So this is the data given. Now we have to calculate the total energy. So what is the formula for total energy? I told you total energy is nothing but pressure plus kinetic energy plus potential energy. Pressure we already know is this much. This is P already given. Now let us calculate what is kinetic energy. Kinetic energy formula also I have given half rho is 10 raised to 3. V square will be 0.1 the whole square. Okay. Next is the potential energy. The potential energy is given as rho g h. That will be 10 raised to 3 into gravity is 9.8 and height is given as 50 centimeters. So 50 into 10 raised to minus 2. Okay. Now we'll let us add all the answers. Pressure, kinetic energy and potential energy. So whenever we take now pressure, it is asked pressure, no? This pressure is asked per kg. So pressure per kg will be, how much is the pressure? We had calculated 20 into 9.8 into 10 raised to 6. This is given in the question, okay? So that's why you have to divide it by 10 raised to 3. So that will be 10 raised to 6. Now total energy will be pressure per kg plus your kinetic energy plus your potential energy. Now add all the answers. 20 into 9.8 into 10 raised to 3 plus your kinetic energy half into 10 raised to 3 into 0.1 the whole square plus 10 9.8 into 50 into 10 raised to minus 2. Now if you calculate your total energy, okay, you can take out 10 raised to 3 common everywhere. So this will be 20 into 9.8 plus 10 raised to 3 is gone out. So 0.001 upon 2 or 0.1 square upon 2 and then 9.8 into 0.5. So this will be 10 raised to 3. Okay, and then this you multiply, you'll get it as 196. This value will be 0.005 plus this will be 4.96. This is total energy. If total energy was asked now, then this would have been your answer. That is 200 joules into 10 raised to 3 joules. Okay, irrespective of how many kgs they had given. Now suppose if they had asked total energy of 1 kg of water. So you'll have to divide it by 1 kg. Suppose if they had said 2 kg of water, then this answer you have to divide by 2 kg. If they had said 5 kg, then you have to divide by 5 kg. The total energy will be into 10 raised to 200.9. Suppose 1 kg means 10 raised to 3. So answer will be 200.9 joules. Now second question. Total energy is basically, remember, pressure plus kinetic energy plus potential energy. The reading of a pressure meter attached with a closed pipe is 3.5 into 10 raised to 5 Newton per meter square. On opening the valve, of the pipe, reading of the pressure meter is reduced to 3.0 into 10 raised to 5 Newton per meter square. Calculate the speed of water flowing in the pipe. So consider there's a pipe here now. Before opening the valve, after opening the valve. The same logic, Bernoulli's theorem only, potential, all the total energy will always remain the same. So before opening also and after opening also. So what all is given? P1, 3, starting there was maybe 1 pressure, 3.5 into P2 is 3. Calculate. The speed. So before opening the valve, obviously the water is not flowing. Water is at rest. So before water is at rest, and after that, obviously it is flowing. After opening valve, the water will flow. So it will have some velocity. So before opening, what is going to happen this side? V1 will be 0. So we consider V1 this side. V2 will be some value which we have to calculate. So as per Bernoulli's theorem, what is going to happen? The total pressure always remains the same. The total energy. So which is the formula I've given for your constant pressure P1 plus half rho V1 square plus rho GH P plus half plus rho GH. So this side I told her just use 1, this side it will be 2. Now the thing is, it's the same pipe now. There's no height difference. So what you have to assume, H1 equals to H2 equals to H. So H also will remain the same. Now there is no height difference in the pipe. So what is going to happen? H will remain the same in the horizontal pipe. The pipe is not, height is not changing. So this term and this term will cancel out each other. Because density is remaining the same, gravity is also same, height is also same. Whether it is before or after. Now substitute the values. P1 is 3.5 into 10 raised to 5. Density of water, we have to take it as 10 raised to 3, I told you. V1 square is anyway 0. Pressure 2 is given as 3.0 into 10 raised to 5 or 3 into 10 raised to 5 and half. V2 we have to calculate. And now calculate the value. So this is how much? This is anyway 0, 3.5 into 10 raised to 5. So this term I'll bring this side. This whole term I brought this side, so it is minus. So take out 10 raised to 5 common. This is a square. Huh? This is 0.5 into 10 raised to 5. Now this will go up, this will come down. 2 will go up, 3 will come. So 10 square is 100. 0.5 into 2 is 1. 10 square is 100. So root of 100 will be V2. So 10 meters per second will be V2. So these are the problem based on Bernoulli's theorem. Remember, whenever there is a horizontal straight 5, when there is no height difference, this will always cancel. Because H1 you have to take same as H. Let's study the next topic now. The types of flows. First one is the streamline. So what does a streamline mean? Okay, consider there is a pipe. Now there are certain points I will mark. Maybe A, then there's a B, and suppose there's a C. Randomly, okay? Might be D. These are some fixed points I've kept inside a pipe. The points will never change, huh? These are fixed. Now maybe water is coming inside. Now, any fluid will be distributed, means broken down into small particles. Consider that one particular molecule came here, that fluid molecule. Okay, so it is going to have some velocity v1 there. And it's having a fixed direction. Whoever is coming at this molecule will be flown this side. Now maybe after that, this point, the same molecule M1 will reach here, maybe at point 2. So then it will go there. At this point, its velocity must be v2. Now the same molecule will come here. Its velocity at point C may be v3. Now the same molecule after some time might reach here because of some force, whatever. Maybe you can consider point D here. So after moving, maybe it reaches here. Okay. Now after M1, maybe there was another molecule which was flowing, consider as M2. Now maybe this one will use it in terms of numbers. So here maybe 5 meters per second. Here must be the speed of this is 10 meters per second. Here maybe 3 meters per second. Here maybe 4 meters. We are just assuming. Okay, at this point, the speed of this water molecule or fluid molecule must be 5. After reaching here, it must be 10. Here it must be 3. Now molecule M2 is coming behind this. So whenever M2 reaches this point A, even M2 will have the same velocity as 5. That same molecule will not go anywhere else in a streamline flow. In a streamline flow, the the molecule will always follow M1 only. So first maybe M1 had come, then M2. Wherever M1 went in a streamline flow, M2 also will follow that particular path only. They always follow fixed path. M2 will go next to point B only. Okay, that one speed also will remain as 10. Again, M2 will go to point C. So that one speed will be 3 meters. And then again M2 will go at point D. The same way, then next third molecule will come M3. So M3 will also follow the same direction and follow the fixed same velocity. Suppose M4 comes, it comes at A and then goes suddenly maybe here at point E. It is not following this path. It is a fixed path. Then it is not called as a streamline flow. Then it would be the next one which we know is called as a turbulent flow, which will flow in any direction, will not have a fixed velocity or fixed point. Okay, streamline flow is what? At any given particular point, fixed point, the velocity of every molecule which comes will always remain the same. It is not going to change. From here to here, between 2 points, it might change. But M1, M2, M3 molecule, even after 10th or 1001 molecule may reach here, still this should remain fixed 10 only. That same molecule should go to point C only. It is like someone is pushing them in the same direction at same point. If they don't follow, definitely they don't follow under streamline flow. So streamline is nothing but it has a fixed direction of a flow at that particular point. Now, whenever a liquid flows such that each particle, every particle means M1, M2, M10, M12, whatever particle flows through a given point, okay, it will always move along the same path and has the same velocity as the preceder. Preceder means okay, the previous one. You can write same velocity as previous particle. So M1, M2, M3, M10, so on will follow path A, B, C, D at given fixed velocity. So maybe particle number 100 comes here. If I ask you what will be particle velocity at point A, it will always be 5 only, it will never change. Particle number 1000 also comes at point A, its velocity will become 5 only. At same the particle number 1000 goes to point B, suddenly it will change to 10 because it is designed suppose in such a way that these are the fixed velocities for this point. They have to follow that. That is called as a streamline flow. So they follow a fixed particular path at fixed velocity. So they are shown in the diagram. Maybe the pipe is like this. It can follow any path, but a fixed path. Okay. So now there's one line of fluid which is coming here. So they will follow that same line. All the particles which are following will follow this path. Again, more molecules will come. They will follow this path only. That is infinite lines are there. Okay. Between every so they will follow a particular path on. If from here suddenly they shift, then it is called as the next one turbulent. The turbulent flow, you don't have a fixed velocity, it will follow any zigzag path also. It will continuously, not necessary, it will fix. After going to A, it might suddenly jump to C. Molecule number 3 might not even go here. They don't follow the previous one. They follow their own path. That is called as a turbulent path. So there are some properties of streamline flow given. In a steady flow, no. In a streamline, you know that they always flow somewhere or the other. They should never intersect. If one path is intersecting another one, is this direction, this is one line of molecule, is intersecting another path of another molecule, then it is not a streamline flow. They should never intersect. The line should go always in a different direction, making sure they don't intersect each other. If you see this diagram, you will understand. Then the note that is going straight away. All are going in one particular direction, there is no intersection. But in case of turbulent, this path at some point they will come and intersect each other. Next, second one, first property is no intersection. Second one, fixed direction. At any given point, it will have a fixed direction. Third one, greater the streamline, larger is fluid velocity. Means what? Suppose if there are only 3 lines, this has less velocity. Higher velocity. Greater, more the number of streamlines, more will be the velocity of the liquid or the fluid. And the fourth property says velocity remains constant. At a fixed point. May be different at different points. What I'm trying to say is, I told you, A might have 2 meters per second. B might have 10 meters per second. Different points may have different velocities, but at that particular point, it will always remain fixed. This is also fixed. Among this may be different. It may be different from different points, but at that particular point, it will always remain 2 meters per second only. A cannot have 2 meters also, and sometimes it shouldn't shift to 3 meters. 2 means 2 only. This fellow and this fellow might have different. Not necessary, here it is 2 means here so it should be 2 only. So velocity remains constant at a fixed point, may be different at different points. So these are your properties of streamline flow. Now, whenever many such streamlines, so suppose this is one streamline, which will have another some fixed path. There might be another one line. It's like placing many streamlines together. This is another one, this is another one. Okay, so like any liquid will flow in the form of strips, and that is called as a tube. It flows in a tube form. So you can imagine a liquid is distributed as form of layers. So these layers, like combined together, looks like a tube flow. Flows in like a form of a tube. So a bundle of streamlines. So this is called bundle of streamlines. Together is called as a tube, and the flow is called as tube of flow. So all these boundaries are parallel to the velocities, whichever side the velocities are moving, it will be parallel to. Now this fluid cannot cross the boundary and come out. So it will always follow a fixed boundary only. Now if the boundary is designed to be like this, this fluid will not flow out. It will always flow within the boundary. So it will follow the velocity in such a way that it always goes parallel to the tube. This will not happen. Suddenly it is not going to come this way. It is going to take the path of the tube. Like, so velocities always will be parallel to the tube. Next one is the turbulent flow. Turbulent flow will be what? Now, whichever, like for a streamline is like a distant flow of liquid. They have some fixed velocity. Okay. Whenever you have a streamline flow, they follow all the rules and regulations. They are like good students, always following the path. Now, there will be some like particles who will not follow the rules. Means that velocity that this is like within the limit. The speed of the water is within, or the fluid is within limit. Now suddenly the speed of the liquid is beyond its capacity, beyond a certain point. That is called as the critical velocity. If that those molecules crosses this, so they start misbehaving then. Okay. First they were very decent when they were below this velocity, but after a certain critical velocity, then they start misbehaving, and then they start running anywhere, and that is called as a turbulent flow. So the liquid flow will become zigzag type anywhere. The path and the velocity of the liquid will change. Here, no fixed direction. So your direction changes, velocities also changes. Zigzag path. Continuously it will change at every point. It will not follow the same path anywhere, anytime. You cannot predict which side it will flow. Under streamline, you know that next molecule will come at point A only. Then it will go to point B only. Here, no, you cannot predict. And the third type of flow is laminar flow. Now what is the difference between a streamline flow? Streamline flow, not necessary, it has to be parallel. It can go in slightly, it can spread out also. Could be like this also. This is a streamline. It is a fixed path, it is having. But what is the specialty of laminar flow? Laminar is always parallel line, straight, parallel, proper. There's no gap and all increasing. Here they are not meeting each other, but they are not parallel also, because this distance might be this. But over here, everywhere at every point, always the distance will remain the same. That is called as a laminar. So velocity is less than critical velocity. Less than critical means they will always behave properly. For turbulent, it is more than critical velocity. Steadily means smoothly. Slow and steady, smoothly and slowly. And very important, parallel. parallel streamlines. Okay, always parallel. Flow in parallel lines. Parallel flow. So this is streamline, turbulent, and laminar flow. Now, what decides what kind of flow is decided by the something called as a Reynolds number. Because it's not possible to go and put something and check everything, this water in which direction, because this all these things are at minute level. You cannot simply just look and say, oh, this water fluid is flowing in a streamline flow, this is turbulent. You cannot directly predict. So what they do is they always calculate in terms of Reynolds number. So the formula for Reynolds number is given as okay. So this is Reynolds number RE. It's a it has no dimension. It's a ratio. Okay, there's no dimension. Like how we have Newton per meter and all, it doesn't have any dimension. Same like strain doesn't have a dimension. You cannot, means no unit. How we have Newton per meter square and all, it has nothing. It's just a pure number. Rho is the density of the fluid. It's there in the notes. It's not needed to write actually. And V is the velocity. So D is the diameter of the pipe from where the water is flowing out. Or not water necessarily, it could be any fluid also. Diameter. And this is coefficient of viscosity of liquid. Means what? It basically tells you the thickness of the liquid. Means different fluids will have different coefficient of viscosity. Water might have something else. I told you another example of honey. Honey, you have seen the flow. Why? It doesn't flow very fast. It is viscous. It is thick in nature. Okay, thicker fluids will take more time to flow. Thinner fluids will flow faster. So every fluid will have a certain fixed constant coefficient of viscosity based on what material it has. So water will have different coefficients, honey will have different coefficients, kerosene will have different based on the density, how dense it is, how many molecules are there per unit area. Okay, so this is the coefficient of viscosity. It describes the thickness of the liquid. So now if the Reynolds number, after calculating all this, putting all of this, they calculate a Reynolds number. If it is lying between 0 to 2000, then it is called as a streamline or laminar flow. If Reynolds number is more than 3000, then it is turbulent flow. And now if it is exactly between 0 to 2000, we know. Above 3000 also we know. But what if it is falling between 0 to 2000? It's unstable. You cannot predict. It might go in this category also. It might fall in this unstable flow. May 5th to streamline or turbulent. Okay, cannot predict as such. It might suddenly change to this one, or suddenly it might go above 3000. Sorry, this 0 to 3, this 2 to 3. 0 to 2 is fixed. So it is like this. This is laminar or streamline, unstable, and 3000 and above is turbulent. So this can shift, this can jump into this also, this can jump into this also. So this is about Reynolds number. Next is equation of continuity. What equation of continuity says it? This area may be A1 and this area may be A2. Equation of continuity, what it tries to say, no? A1 V1 is always equals to A2 V2. Basically, it means A into V is always constant. Means what is, if area is big, velocity of the flow will, speed of the fluid will be less. So total multiplication should give you same number. Suppose if this is 5 and this is 4, suppose I should get 20. Suppose A into V is giving me 20. Here also A into V should be 20 only. So if area is suppose 2 here, if area is suppose 2, then what will happen? This cannot change. Okay, area is fixed. Now suppose area was 5 here, but area is 2. But this 20, whatever A into V should have been 20 here. So accordingly, speed will change now. Speed will become 10 in order to give me 20. So if area is big, speed is small. If area is small, then the speed will increase. You must have noticed. Suppose when you are putting water with a pipe in the garden for the plants and all or anything, or even if you go and keep a hand on the, what is that, tap, or try to block half path of the tap. So keep your finger, obviously you will see that the water is going to come at a faster speed. Why? It is because you are trying to reduce the area. So if you try to reduce the area compared to the original one, you will have less space. There will be more pressure. Right? Velocity of the water, the force acting per area, okay, smaller area means higher will be the pressure and velocity will increase. So that's why you will feel that the water is coming at a higher speed when you try to block the end of the tap or block the end of the pipe. So equation of continuity says A1 V1 is always equals to A2 V2. How they get it is all that is there in the notes. Consider non-viscous. Non-viscous means proper flowing one, not that like honey and all, like proper water and all, which is flowing nicely. incompressible means you cannot change its density. So A1 is the cross-sectional area on one side, or pressure is on that side, and this. So what is the mass of this? Mass of the fluid entering will be, you know that what is density? Density is always mass upon volume. So what will be mass? Density into volume, or volume into density, because density is always equals to mass upon volume. So mass will be always say volume into density. Again, volume is nothing but area into always its length. We know that whenever you have any box, cube, it's always area into its height. So area into its length. If it's a cylinder, we always take the circumference into height will always give me the volume. Area into height or area into length will always give volume. So volume is always area into length. And this will be density. So at the starting, so this is cross at A and this is at point B. At point A, mass of the liquid we are assuming to be M1. And this side mass we will assume it to be M2. So just put it here, mass of the fluid at point A, M1, area will be A1. Okay, again, before that if you want, before writing point A, length is nothing but distance. So what is velocity? Velocity is nothing but it is distance upon time. Distance means length, so velocity into time will give me length. Distance is nothing but the length. So velocity into time into density. Speed is nothing but speed same as velocity, distance upon time. So distance will be velocity into time. So distance is nothing but your length. So at point A, M1, area will be A1, velocity will be V1, time will take it as delta T. For that much time here, it is flowing. And density will be rho1. At point B, same way, everything will be M2 now. Put everywhere. Time will not change. We are considering if it is flowing for 10 seconds here, so we are calculating it is going for 10 seconds here also. The time will be calculated for fixed amount. If we are calculating for 10 seconds, we are assuming whatever it is for 10 seconds. So that will keep it same. Now we know that at even any point, the mass of any object or any fluid will never change, because we are assuming it is incompressible. Means whatever, like if you are sending 1 liter of liquid, obviously 1 liter of liquid only will come out on the other side. It will not become half liter and come out. So mass will never change. So by law of conservation of mass, M1 is always equal to M2. As for that, also fluid is incompressible. We are assuming it to be incompressible, means density cannot change. So sigma 1 will be equal to sigma 2. Sorry, rho. Rho 1 will be equal to rho. Density, whether it is at the start of this pipe or at the end, the density of the liquid will never change. Means suppose you are considering water. Here also it will be 10 raised to 3 density. Out while coming out also it will always be 10 raised to 3 only. Density of the water will not change. Density means how many molecules are there, how dense it is. The structure of the water will not change from here to here. So equate this M1, M2, equate your right hand side. So rho 1 equals to rho 2, we'll assume it to be rho. A1 so this and this will cancel, time and I will cancel. So A1 equals to A2. So if area increases, if area decreases, velocity increases, and vice versa. If you increase the area, velocity of the fluid will decrease. So this is what it tries to say. So there is a question there. One problem is there. It's very simple. Just go through it. They have just given directly the area. Just use straight away the formula. So it's a circular pipe given. So area is considered as area of a circle. So pi r square. Diameter is given. So you have to divide. Radius will always be diameter upon 2. You can calculate the radius and then substitute and solve. Already solution is there. So it's a simple one. Directly use the formula. Area will be pi r square. It will be r1 now. And pi will cancel. Whatever diameters are given, you can find the radius, substitute here, calculate. Next is the Stokes law. Stokes law says that there is always some kind of opposite force which will try to act on anything. And suppose if you are riding a bike, okay, consider you are riding a bike and you're going this side in the front direction. If you notice, there'll be always air or wind blowing in the opposite direction. So whenever you face this air coming towards you, it's like kind of a resistance. Okay, this is in the opposite direction. You are flowing this, going this side, and if air is going this side, then it is trying to resist. Anything coming in the opposite direction is called as a resistance. Because suppose if it is flowing the same way, it will always help you move faster. You would even fly along with the wind this side. But whenever it's opposite, it tries to restrict you from going front. Just imaginary way. Okay. So this opposite force is called as a drag force. Okay, it may be called as a drag force. Now, since this Stokes law is referring it to some liquid, okay, now what tries to tell is now there's a liquid and suppose there's a pipe. It's like suppose a tank, it has a fluid. Now you throw a spherical ball, okay, we want a symmetrical body, okay, so that's why we try to throw a spherical ball inside this fluid. Now suppose this fluid density is rho. This one density is considered rho. What they have given here. One second now, because different textbooks they give different notations. On the notes I'm referring the viscosity. Okay. Will this density will come across later for the derivation, but now try to think on this point of view. For the force, anyways, it is not needed. So if you try to drop a suppose spherical ball, so now it is obviously it will not float. And suppose it's a heavy one, consider it is coming downwards now. Okay, this ball is slowly trying to move towards the bottom of the liquid. So as per Stokes law, what he's trying to say is he is taking a viscous liquid. Viscous means thick liquid. There is some thickness. So the ball will suddenly not reach at the bottom. Imagine you're putting something in honey, the thick liquid. And imagine if there was water. So you compare. Obviously the spherical ball will reach quickly in the at the bottom of the what is that water faster compared to this honey. Because it is thick, so it is what trying to resist the movement of the spherical ball downwards towards the bottom of the this. So why is it taking time to reach compared to the water is because there's a force which is acting upward. And that force is given by F. That is the drag force. Okay, I'm just naming it as drag force. So it is acting upwards, trying to resist it. And that force formula is given by the Stokes law. 6 pi this is pronounced eta, not theta, eta. Would be V. Where this we have already seen the coefficient of viscosity. Okay, eta is nothing but the coefficient of viscosity. Then r is the radius of the sphere. And v is the velocity. So according to Stokes law, the backward viscous force. Backward means this is front, forward. This is going forward, and this is like backward. The backward viscous flow, this force acting on a small spherical body of radius r, okay, moving with a uniform velocity v. Suppose this is coming with a speed v, then the force which is acting backwards is given by this formula. So this is Stokes law. So 6 pi nRV. You can use the letter n only. You can say if you are saying eta. So force depends on what all things. This is all constant. The radius. This based on it changes on different fluid. So it depends what kind of fluid you are using. Depends on how big the sphere is, and depends on how fast you throw the sphere, with what speed you are throwing the sphere. So there's a derivation. For that, there's something called as a terminal velocity. This is a maximum constant velocity acquired by a body while falling through a viscous medium. Means what is, you could throw this at 10 meters per second, you could throw this at 20 meters per second, you could throw this at 40 meters per second, but there'll be a certain limit for every particular liquid. Okay, so comparatively, now you are trying to experiment throwing this sphere. So you are throwing maybe at 50, maybe at 20, okay, based on the different fluid, maybe 30, 60. So you calculate it. So maximum, like no matter how fast you throw, not necessary with that same speed it will reach down. So after reaching the fluid, obviously speed will change because of this force, even though you may throw it at 50. But after calculating all this might turn out to be 20. No matter how fast you throw, there will be a fixed constant, maximum constant velocity beyond which it cannot go. So maybe for this fluid, if it is 30, even no matter at what speed you throw, after reaching here, the maximum which it can gain is, it can move throughout till the bottom would be 30 on. Okay, so there's something called as a terminal velocity for every viscous fluid. So that maximum constant velocity is called as terminal velocity. Now the derivation. Same thing, consider sphere. So it's all there, huh? In the notes, consider sphere, a spherical body of radius r, falling through a viscous fluid of density sigma. So this one's density of the fluid is given as sigma. Coefficient n of the fluid. And this rho is density of body. Okay. So what all is there of the spherical body? R is the radius and rho is its density. M is the mass. Then consider viscous fluid. This fluid. It's like a thick fluid. The N is its coefficient of viscosity. This is its density. This is density of the sphere body. This is density of fluid. We cannot use the same symbol because this density will be different from this one. So this we have used rho and this we have used sigma. Okay, V also used, that is velocity of sphere, velocity of the body which it is coming to. Now what is going to happen? Now consider this body is falling in that liquid. Obviously, why is it coming down for the first place? Because of its weight, no? Weight of the this is pulling it downward towards. Why is it? Because mass into gravity is coming down. The once you throw, the spherical body is trying to come to bottom. Why? Because of its own weight. Because gravity is pulling it. So there's a downward force mg. For any load, we know that always mg will be acting downward. Now, as per the Stokes law, there is a force which is acting upward. Okay, so what all is there? Just draw it properly. This is mg which is acting downward, and this is F which is acting going upward. This is as per Stokes law. That is a drag force. And for any other this also body, there's as per the flow, what is that? Flotation, law of flotation. There's always another force which is acting upward. That is called as the upthrust, or the buoyant force which we had seen. Buoyant force also tries to act upwards, which tries to make it float. But sometimes what happens is downward force weight is always more than the upthrust or the buoyant force. So upward, which all two forces are applying is the upthrust and the Stokes law, and downwards there's only its weight which is coming. The first one, the downward force, the weight of body acts vertically downward. So what is the weight given as m? So which is same as I told you, mass density is mass upon volume, so which is rho v into g. So volume of the sphere will be 4 by 3 pi r cube. So this v is, not be careful, this v is volume, capital V value, volume, not velocity. This small v value is for velocity of the body. The volume of the body will be 4 by 3 pi r cube. Now second, which all the forces we are calculating now. Second force is, consider upthrust, U, that is same as for buoyant force. Want you can write, otherwise it's okay. There's the upthrust as so that is given as, obviously it will always be equal to the weight. Whatever is the weight, no, equal and opposite will try to act. So always equals to the weight of the body. That also will be 4 by 3, same thing, pi r cube. Only thing now, instead of this density, we'll have to use this. Why? This was density of the body. Now upthrust is coming from where? From the fluid. So density will be density of fluid is sigma. The only difference between this and this is you have to use the density of the fluid now, because this upthrust is coming from the fluid and weight is coming from whom? From the body. So it will be density of the body here. And here it will be density of the fluid. Rest everything is same. And the third one is the Stokes law. Is for so that is given as, so it is upward. 6 pi nr. At equilibrium, or means you can say equilibrium only. At equilibrium, all the forces means what? Upward forces will be equals to downward force. Which all are the upward forces? There are two upward forces now. Downward only weight is there. WT means weight, huh? So what is this given as? U we have calculated as 4 by 3 plus this is the Stokes law, and weight is now bring this full term on one side. This is pi. Okay, we reverse will take otherwise 1 second, huh? Because otherwise this if we take this side it will become again minus, we'll have to change the sign. So what I'll do is keep this here on 6 pi nRV. This fellow I'll take on the other side. This full term, take it on the other side, so it will become minus. Because we have to calculate velocity. So whichever term I want to calculate, I'll keep it this side. The rest of the things I'll take on the other. Now if you see, everything is common. 4 upon 3 pi r cube g is common. Only what remains inside is this. Now you can cancel 0.5. Or before you can do this way also. V is what? 4 upon 3 pi r cube g rho minus sigma. Now this only V I want to calculate. So all this what will happen? They are multiplication. So they will go to the denominator. Now cancel. 1 r will go this square. 3. Answer will be 2 by 9 r square g. Okay. 3 3s are 9. So this is the answer for terminal velocity, Stokes law. I'll stop here. Actually, in the notes, it's given up till here, but there are 2 more topics. They are on the textbook, so I'll do in the next class.